All right. I've been asked to leave a few minutes for the evening, but you've actually just done something truly remarkable. We have just discovered, if you were to get your bicycle out in the evening and go for a bike ride from your garage, like I do most every evenings, ride some great big loop, come back to where you started, every evening do a different loop. The area between the tracks on your bicycle path, no matter what you do, you have no free will. The area is going to be pi. No free will.
As long as the one distance is
Pi r squared, where r is defined to be 1.
Yes.
Right, there is always pi r squared.
But what if you have concave?
Then the natural question comes, what do you do if I don't ride a nice concave loop? For example, what if I did a polygon like this? Let's stick with polygons. What would the front wheel track now look like?
You got some negative curves.
And we have crossing, right? Nice changes.
Then there's something interesting to mull on. Some people tell me you might have to start counting some areas positive and some areas negative. And I'm also hearing people tell me still answers going to work out to be pi in the end. It seems remarkable.
Yeah.
It's like people on what's on this paper might have to say, if I'm bending one direction, count that as one type of area, like a positive area or negative, just make up your mind which one you want to be. But as soon as you start changing direction, count that as a negative area. All right. I'd like to know if that's true, that the area is always pi, even if it's a concave curve you're writing in, if you really consider positive and negatives. And then, I would like to know, how would I even compute the area on a non-closed loop? On this piece of paper, we had a starting angle, we had a finishing angle. Maybe you can even figure out what the area is between the humps we're seeing on this very piece of paper.
No, 0.
So you look at the difference of your
So there's something to think about.
So it's either 0 or pi, right?
Right. 0 pi. But of course the real question is, open research is still, is the circle the only case when straight line you can't tell which way the bicycle went? And that's the one I personally would love you guys to seriously think about and email me next week or next month or next year or next decade with an answer, because I don't know the answer. That would be really cool. And mathematicians are often surprised by this. They would say, oh, just write the differential equations for this. Surely you could work and just prove the solution exists. Easier said than done. That's all I can say. And I think knowing too much knowledge for us professors is actually sometimes dangerous to us professors. You know, kids are fabulous what insights they come up with that just I would never think of, and they're just brilliant. That's why I love working with the kids and the teachers and everyone. Math is just cool. So let's end there, except we should end off with the math salute. So I'll make sure you learned it. Yeah? So I'm going to watch seriously this time. We're ready? Alright, for the final evening math salute, arms out front, right over left, palm to palm, wiggle the little fingers, wiggle the thumbs, wiggle the little fingers again, and then when you're ready, just come on back. Awesome, good job guys. Well done. Thanks.
Learned something new. Thank you. Great job.